2.3, multiplying polynomials. So you've learned how to name them, you've learned how to add and subtract them, now we're going to learn how to multiply polynomials. In the next lesson, we'll learn how to divide them. So I have a binomial here, a linear binomial, x plus 5, and I want to multiply it with another linear binomial, x plus 3. And there are two methods that you're going to learn. The first is called the FOIL method, and the second, which is on the later pages, is called the box method. Okay, both are helpful and both are good to know and both make really good sense. This is a little bit of a long lesson, however, it's kind of easy. However, you will use this method for the rest of your math life, so it is really important that you get a solid understanding of what you're doing. Okay, when you, double distributive is something I use also to refer to the FOIL method, but typically I'll say, oh, just FOIL those two binomials, okay? But double distributive might make sense to you because if you had something like 2 times x plus 3, that would be a constant times a binomial. You would distribute 2 into the parentheses and you would get 2x plus 6, right? Right. So now I have a binomial times another binomial. So we have to do what's called double distribute. Basically, I have to distribute the x into the x plus 3 parentheses, like so. Then I have to distribute the 5 into the other binomial, x plus 3, and I would get my solution. Okay, well, there's a really organized way of doing this, and it's called the FOIL method. Okay, FOIL, the F stands for first, the O stands for outside, the I stands for inside, and the L stands for last. So if I look at my first, this is my first term in each of my binomials. If I multiply my first term, I'd have x times x, and I would get x squared. Now, the O stands for outside. So I'm going to look at my binomial, and I'm going to say, okay, what are my outside terms? Okay, this x is the outside of the two binomials. This 3 is the outside of the two binomials, right? Because they're kind of on either ends of this expression. So if I multiply x times 3, I get 3x for my outside terms. Okay, now I stands for inside. So I'm going to take the two inside terms. 5 and x are the two inside terms. If I multiply those, I get 5x. And then my last term would be 5 times 3, which is 15. Okay? I'm going to combine all of those together, which will give me x squared, because x squared is not a like term with anything else. 3x and 5x are like terms, so I'm going to put those together, and I'm going to get 8x, and then 15 is a constant, and I'm going to write that last. It is good form to write this in descending order, meaning your highest exponent first, and then go down from there. This is the exponent of 1, this is an exponent of 0. So my final answer here is x plus 5 times x plus 3 equals x squared plus 8x plus 15. Okay, box method, same problem. I set up x plus 5 along the top, I set up x plus 3 along the side. These are interchangeable because multiplication has the commutative property. So x plus 5 along the top, x plus 3 along the side. Now, I multiply to find the area of this square right here. Well, the top length is x, the side length is x, so x times x is x squared. I multiply this 5 by x and I get 5x. I multiply this x by this 3 and I get 3x, and I multiply this 3 by this 5 and I get 15. Now I wouldn't just leave it like that, I'd need to kind of put everything together, so I'd look and see where are my like terms. Well, x squared doesn't have any like terms, so I'm going to leave x squared by itself. 5x and 3x, they are diagonal from one another, which is a little bit important to note for later. I get 8x, and then I have 15. So I get the same answer. Some people really like the box method, some people really like FOIL method. Your call. So here's another problem we're going to do. I'm going to do them both ways so we can practice them. Okay, first I'm going to multiply 2x times 3x, and I get 6x squared. Outside, I'm going to do 2x by 7, and I'm going to get 14x. Inside, I'm going to do negative 4 times positive 3x, and I get negative 12x. And last, I'm going to get negative 4 times positive 7, which is going to give me negative 28. When I put those together, I have 6x squared. 14x and negative 12x will give me 2x, and negative 28 is my final term. Okay, just to erase this so you can see it, now we're going to do this using the box method. I take 2x minus 4 and I line it up along the top, maybe 2x minus 4. I could switch them as I said before. 3x plus 7 along the side. Now I multiply to find the area of each box. 3x times 2x is 6x squared. 3x times negative 4 is negative 12x. 7 plus 2x is 14x. 7 times negative 4 is negative 28. Again, like terms get put together, 6x squared as I have here. Negative 12x and 14x are like terms, so I'm going to put those together and I get positive 2x, and then negative 28 I'm going to put in that term right there. And there's my final solution. Great. All right, then as you move along in this lesson, you'll see that then you start to have not just a binomial times a binomial. Now I have a linear binomial times a quadratic trinomial. Well, how that would work is one of two ways. One is using the distributive. So you distribute the x into these parentheses, you distribute the 7 into these parentheses, and then you combine like terms. Okay? It's really messy. 4x to the third plus negative 6x squared plus 4x. That was just doing the x. Now I'm going to multiply 7 into the parentheses, plus 28x squared minus 42x plus 28. Okay, now I look for like terms. 4x to the third doesn't have any like terms. Negative 6x squared and 28x squared. Those are like terms. 4x and negative 42x. And then finally, positive 28. So if I put them all together, I get 4x to the third. Notice how I'm doing it in descending order as well. And then I'm going to go to my red term next, and I'm going to get positive 22x squared. And then my green term next, I get negative 38x plus 28. And it's in descending order. And that's my final answer. Kind of messy, I must admit. Oops. So now if I look at this sheet and I have to extend my page a bit. You can use the box method, which actually I think makes a little bit more sense in this case because you don't lose terms as much. It's very easy to make mistakes when you just use the distributive method there. So here I have I have 4x squared minus 6x plus 4, and then on the side I have x plus 7. Now if I multiply these two, I get 4x to the third. I multiply these two, I get negative 6x squared. I multiply these two, I get 4x. I multiply these two, I get 28x squared. I multiply these two, I get negative 42x. And I multiply these two, and I get 28. Notice, too, again, how the like terms are diagonal from one another. That one doesn't have anything that's like. But these two are like terms, and they're diagonal from one another. These two are like terms, and they're diagonal from one another. And the constant doesn't have anything that it combines with. Okay? So again, if I combined the like terms, I would get exactly what I got up here, and I would have the same solution. Two methods, same problem. Moving on, there's two more kinds. The first one is called when you have a binomial squared. Okay, a binomial squared. Well, if I have a binomial squared, I'll explain this word verbiage in a moment, but if I have a binomial squared, what that means is I'm basically going to write x plus 7 times x plus 7. People make mistakes with this all the time in algebra and beyond. So I encourage you to write it out twice and then use your FOIL method or your box method. Here I'm going to use the FOIL method, x squared plus 7x plus 49, or x squared plus 14x plus 49. Same here, I have x minus 7 squared, so that's x minus 7 times x minus 7. And when I FOIL it, I get x squared minus 7x plus 49. I'm really good at this. That's why I move so quickly. X squared minus 14x plus 49 is my solution. Notice how these answers are similar. The only thing different here is that this has a positive 14x and this has a negative 14x. But if you look back at the problem, it said x plus 7 squared, which got me a positive 14x. This says x minus 7 squared, which gave me a negative 14x. Okay? So these two circled things are called perfect square trinomials. They're trinomials, right? And they are a perfect square because I squared a binomial. Just like if you had 3 squared, it equals 9, right? So 9 is what they call a perfect square, right? Same idea. Okay, last one here. I've got 2x plus 4 quantity squared. I can FOIL it, but I'm going to use the box method here. 2x plus 4 is on the top, 2x plus 4 is on the side. I get 4x squared, I get 8x, I get 8x, I get 16. The final answer is 4x squared plus 16x plus 16. And we will find patterns within this, but just not quite yet in this lesson. Okay, last thing, called a difference of two squares. Very fun. In the next chapter, I call this a DOTS, or dots, just like the candy. Guess what? You earn candy in this lesson too because you learn how to FOIL, so you get some candy that's in FOIL. In the next chapter, you'll get dots candy for learning more about difference of two squares. So let's begin that process by looking at what I've got here. Now I have two binomials I'm multiplying. One is x plus 4, the other one's x minus 4. Look at all of these. X plus 5, x minus 5. 2x plus 4, 2x minus 4. Okay? Whereas in the last one, they were exactly the same. They were squared. In this one, they're almost the same, but they just have one tiny little difference. This is a plus, this is a minus. Okay? So if I'm going to multiply this out, I'm going to get x squared. I'm going to use FOIL here. My outside gives me negative 4x. My inside gives me positive 4x. And my last term gives me negative 16. What happens when you combine like terms with all of these is that you get x squared, but the two middle terms cancel out. So my final answer is x squared minus 16, or a difference of two squares, because x squared is a perfect square, 16 is a perfect square, so it's a difference of two squares. So when I look at this problem, I just know the answer right off the bat because I know it's going to be a difference of two squares. It's going to be x squared minus 25, a difference of two squares. But let's say you don't know it yet because you're just learning it. X times x gives me x squared. The outside gives me negative 5x. The inside gives me positive 5x. And the last term gives me negative 25. When I combine the like terms, I get x squared minus 25, which is what I said right there, a difference of two squares. This one here, very similar, but a little bit more complicated because I have 2x instead of just x. If I'm going to use the box method here, 2x and 2x is 4x squared. 2x and 4 is 8x. Negative 4 and 2x is negative 8x. And negative 4 and positive 4 is negative 16. When I combine these together, you'll notice that these two cancel out, as I said they would, and your final answer is 4x squared minus 16, or a difference of two perfect squares. Okay, so take care of the lesson, do all the problems, and then check in with me for some candy.